Today we are going to see law of constant composition. Law of chemical combination. We are going to see one law, that is law of constant composition. Okay, law of definite properties or constant composition. Both are same. Okay, definite properties means also constant composition means also the same. So let me see what is a law. A pure chemical compound always contains the same elements combined together in the same definite or fixed or constant proportions by weight, irrespective of its source or method of preparation. Which means I will say, for example, any chemical any elements is involving in the chemical reaction. Any elements is involving in the chemical reaction. It will give some product. Okay, it will give some product. So, how many amounts? How much mass of the how much mass of the reactant which is equal to how much mass of the product. Otherwise you can understand from this. For example, any element you can take, that element is prepared. Any element I'm so sorry, any product. Okay, any product, sorry, any product we got. Okay, we got any product and it will be prepared by two methods, first method and second method. We got the same product. For example, CuO, this is one of the product. It will be prepared by two methods, first method and second method. But in the both method, the same amount of copper and oxygen will be used. Okay, so the same amount will be remain. That only they are saying a pure chemical compound always contains the same elements combined together. Same elements combined together in the same definite fixed amount. The same fixed amount it will be remain. Okay, so that only law of definite properties or constant composition. Any product we got, it will be prepared by various methods, but the same fixed amount will be remain. Okay, so that is known as law of constant composition. I will say one example, then you can understand easily. Okay, for example, copper. Let me take copper. Okay, copper is prepared by using two various methods. Okay, two various method it will be prepared. From copper nitrate it will be prepared, otherwise from copper carbonate it will be prepared. I said no, two methods. So this is the first method. From this we will get cupric oxide, then we will get copper. Like that, from copper carbonate also we will get cupric oxide, then we will get copper. So detailedly I will explain this chemical reaction later. First I am just explaining what is mean by law of constant composition. Okay, so I said the product, no, it will be prepared by two various methods. This is first method and this is second method. But in the two methods we will get same amount of what I said, same amount of the fixed amount will be remain. Okay, that only we are saying. Now see the example. Verification of constant composition. I said no, from two methods CuO will be prepared. So this CuO, cupric oxide, will be placed in the porcelain board. This is known as porcelain board. The two samples from two various method we prepared the CuO. Okay, so that CuO, cupric oxide, will be placed in the porcelain board and it will be placed into one glass tube. Then the hydrogen gas is passed through the tube. After heating, this cupric oxide will be separate, copper and oxygen separately. Okay, we have to prove that copper and oxygen will be same amount. The fixed proportions will be remain the same. That one we have to verify through this diagram. Okay, so let me see the first method. What is the first method? I said from copper nitrate we will get cupric oxide. After that, this cupric oxide we are passing the hydrogen in the diagram, then it will separate copper and oxygen. Now see, 2CuNO3 2. What I said, this one is copper nitrate. From this copper nitrate, copper will be remain plus oxygen plus nitrate. Okay. See how many copper here? 2, so 2. Everything was equally having. Now this CuO, we are taking 1 mole of CuO. Then we are passing hydrogen. In the previous diagram I said no. In the diagram, CuO will be placed in the porcelain tube. Then we are passing the hydrogen gas. After heating, what we will get? This H2 and this oxygen will join. Then water molecule will form. Then this copper will be remain. This is the first method. From this method, we are going to calculate the weight calculation. Okay. Now, what we have to prove? The same amount, the fixed amount of proportions was remain. That one we have to prove. So, weight of, we are taking here what? From cupric oxide, we are getting copper. So, take this cupric oxide. Weight of cupric oxide. What we know, that one we have to write here. Now we don't know, so just write W1 gram. Now weight of copper. Here we have to write, because we know this copper will be remain here, so we know the value of copper. So W2 gram. Now weight of oxygen we don't know, but we can get V1 minus V2 means we will get the oxygen value. So this one was subtracted from this one means we will get oxygen value. So V1 minus V2 gram. This is the weight of oxygen value. Okay. We already know CuO value here, that is W1. We got Cu, so W2. Oxygen value we don't know. So how we can calculate? From this 2 we will subtract means we will get the oxygen value. So what is the ratio here? Weight of Cu will be in what ratio? Cu is to oxygen is in which ratio means W2, Cu value is W2. So W2 is to oxygen value is W1 minus W2. So these are the ratio. In the first method we are having that. Okay. In the second method, now we can calculate carbonate. We are heating, then cupric oxide we got and carbon dioxide gas will be formed. Then we are taking this cupric oxide plus hydrogen as usual, which was already told in the diagram. Like that we are passing the hydrogen gas. Then copper will be remain and this H2O will be joined. Now we have to prove what is the ratio for CuO. As usual, weight of CuO is W3 gram. Why we are writing here W3? Because here we are already having V1 and V2. So we have to write here what? W3. So weight of copper is W4 gram. Like that, from that we have to calculate oxygen value. Weight of oxygen is, from this we can separate 4 minus W3. Now what is the ratio of CuO is? Cu what ratio? W4 is to W4 minus W3. So this is the ratio. Now we have to prove this through the problems. Okay. 375 gram of CuO were reduced by hydrogen and 1.098 gram of copper were obtained. See here, CuO value they given, W1 value they given, Cu value, W2 value they given already. We have to find out the W3 value. Okay, like that. See here, in another experiment, 1.178 gram of copper were dissolved in nitric acid and the resulting copper nitride was converted into cupric oxide by ignition. The weight of CuO formed was 1.47 gram. Here see, here first they given copper value. They didn't first, in the first problem they given CuO value as W1 and Cu value W2. Like that they will confuse, but we have to clearly understand the question. So here they given Cu values. Here CuO value. CuO was formed. So you should not confuse W1 and W2. Okay. So show that these results prove the law of constant proportions. Okay. So here which one is W4? This one is W4 and this one is W5. Okay. Shall we calculate now? First experiment. First we have to take first experiment. See, weight of CuO is what? 1.375 gram. One, weight of copper is 1.098 gram. This is W1 and this is W2. Now we have to calculate weight of oxygen. We don't know. So like that you have to write the question mark. What is the formula? From this one we can subtract, means we can get the value. So W1 minus W2. You have to subtract 1.375 minus 1.098. The values you have to write here. Then you will get 0.277 grams. So this is the value of weight of oxygen. Now, what is the ratio? We have to write ratio, weight ratio. Weight ratio of CuO is what? Cu what we got? 1.098 is to oxygen value 0.277. This is the weight ratio. Now you can divide this 1.098 divided by 4 means you can get this value. It was divided by 4 means you can get this value. So what ratio? It will be a 4:1 ratio. Like that, for the second experiment we have to calculate. This is for first experiment. This value 1.375 gram of CuO and 1.98 Cu. Now you have to calculate this second experiment. Where is the second experiment? Here. CuO formed 1.476 and Cu 1.178. In both, copper is formed, but in two various methods. The first method we already calculated. For the second method we have to calculate. Second method, what is the CuO value? In second method, what is the CuO value? 1.476. 476. And Cu value is what? See here, where is Cu value? Here is Cu value, 1.178 gram. Now oxygen value, how we will calculate? From this you can subtract, means you can get the value. The value is 0.298 gram. So what is the weight ratio? How you will write Cu ratio? Cu value is 1.178 is to oxygen value 0.298. So you can divide it by 4 means you will get this. 1.178 was divided by 4 means you will get this value. So what is the ratio? 4:1 ratio. So the copper was prepared by two various methods. For the first experiment also we get the same ratio 4:1. For the second experiment also we get the same ratio 4:1. Now we can see the second problem. Problem 1.2 gram of rock salt gave 0.7567 gram of chlorine, while 1.60 gram of sodium chloride obtained by burning sodium in chlorine gave 0.972 gram of chlorine. Prove the law of constant composition. Now write weight of rock salt 1.25. Chlorine weight of chlorine what? 0.7567. Okay, now you have to calculate rock salt means what is salt means what? NaCl. That only they are saying NaCl. From this is the NaCl value, this is Cl value. Now we have to calculate Na value. Okay, weight of Na value is, you have to subtract from these two, then you will get 0.4933. Now write the ratio of Na is to Cl. Okay, Na what? 0.4933 is to Cl value is 0.7567. Okay, this is the ratio of 1 is to 1.5, because you can divide it by this 1 by 1.5 means you will get this value. Okay, second experiment. See, in second experiment what they given, 1.60 gram of sodium chloride. So they given NaCl value. Write the NaCl value, 1.60, and next one obtained by burning sodium in chlorine gave 0.972 gram of chlorine. Chlorine value is 0.972. 0.972. Now Na value you have to calculate. Subtract these two. What you will get? 0.628 gram. Now write the ratio. Na is to Cl ratio is 0.628 is to 0.972. Now what is the ratio? The same ratio, 1 is to 1.5. You will divide this by 1.5 means you will get this value. So the same ratio, 1.1 is to 5 here also. In the first experiment also 1 is to 1.5. So the NaCl was prepared by two various methods. Na, this is the first experiment, this is the second experiment, but it will have the same ratio of the elements. So this is the law of constant composition. Thank you.